that sucks. If you're wondering, I just tripped over my computer cord and ripped it out. So that's a great Friday. Trying to read this comment. I'm sure I've hugged for. That was me tripping over my computer wire, Levant, and ripping it out of the computer. It's okay. I'm great, guys. Thank you for your concern. Just clumsy. I appreciate your concern, though, but I'm all good. I was just trying to read the chat. Because I like to just laugh at myself. Sometimes. It's all good, though. It's just because I have everything stretched super far so that I can sit in front of my board. But welcome back. I hope you enjoyed your easy math day yesterday. As we wait, you can log in. Is it not posted?
No, it is for me. It's posted at
like 7:30
p.m. December 18th.
Yeah. I would try to just refresh. Really, I could probably just send you the code.
It's the third thing down.
Oh, can you see all those topics?
Yeah.
I was always curious about that. There's nothing under them though, right? It just has the dates.
Well, if I click on them, I can see the assignments and stuff, but.
Oh, I didn't know that. Okay. I always thought it waited until the day to post it. That's just me being super prepared for next week. But yeah, so I didn't realize that those showed up even if I didn't actually post them yet. So make sure in Google Classroom, you're scrolling down to the 18th. So there's a couple of days listed there just to get ready for next week. That's what I was working on yesterday. But make sure you're scrolling down to the 18th where it says live lesson. You should open up the Nearpod and it's Unit 4, Lesson 8. That is good to know. So I appreciate you telling me that, Seda. Maybe I'll make sure I don't do that. At least make sure I don't send too many at once. I always thought it stayed hidden until the scheduled time. Interesting. Good to know. But yeah, so as we're waiting for everybody else, go ahead and log in, Google Classroom, scroll down until you see today where it says December 18th, Friday. And again, make sure you're clicking on the classwork section. I don't know how many of you are still just trying to find your assignments in the stream, but that's gonna give you a huge headache, especially if I have a couple other things kind of uploaded into there. Click on your classwork section so you can see the date. Today is the 18th. Go to that live lesson. Go to that live lesson. And like I said, when you open it up, it says Unit 4, Lesson 8, and there's like a rainbow background to it. This does go along with the book. So if you want to use some scratch paper, we're going to start on page 62. What we have been working on so far and what you did yesterday, we were looking at these percent increase and decrease problems. So discounts or markups and solving them with proportions, which is a little bit of work, setting it up and understanding how to do it. So we're going to review that today and then go over the shortcut, easier method. Some of you might already know how to do it, but we're going through method number 2 for solving percentages. For your 9th period, you have an ed puzzle and some practice problems. And then it's Friday, so that's the end of our week. We are going to be pulling names for the attendance lottery today. As far as my class goes, your attendance for yesterday is not going to be counted since I made that decision to kind of give you an independent working day. So it's just going to be if you were logged in Monday, Tuesday, and today. So you don't have to worry about yesterday because I determined that. I just wanted to give you guys a little break day just for math. Okay, majority of us are in, so I'm gonna go ahead and switch here. Hopefully I don't trip again. Okay, so we're gonna look at this first problem. I'm gonna go through this with you just to review the things that we've been doing. So it says money in a particular savings account increases by about 6% after year. So as a little background knowledge, if you have money in a bank, in a savings account, it collects interest over time. That means that however much you have in there, every week or every month or kind of however you have it set up, you're going to gain a little bit more money just from having it sit in that bank. So in this particular account, it increases by 6% after 1 year. We want to figure out how much money will be in the account after 1 year. If the initial amount is $100, what if you have $50? What if you have $200, $125, and then X dollars? So we are going to look at this in a table where X is how much money you start out with, and then Y is how much money is in there after a year. All we know how to do right now is to solve something like this in a proportion. And this is what your work was yesterday with your markup and your discount problems. So we talked about this earlier in the week. All we're gonna look at right now is if your initial amount is $100. So I'm gonna put that on the left side of my proportion. We also talked about how when we're setting up proportions, your initial amount or your original amount always is associated with your 100%. So that's always your go-to to get started with the proportion. Take the number that you know and set it up across from your original 100%. Then I have to decipher what an increase of 6% means. And we talked about how we're adding and subtracting from 100. So if I have 100% and I increase it by 6%, that means after a year, there's 106% of my money in the bank. I just don't know how much that is yet. So then the same thing that we did, that's okay, Alicia. Earlier in the week, cross multiply. So you would do 100 times 106 and then divide it by 100. So in my table, I'm gonna say if I start out with $100, January 1st, I put $100 in my bank account. It increases by 6%. So after 1 year, there's $106 in the bank account. That's what we know how to do right now for solving percentages. We talked a little bit on Tuesday, I think, whenever we did the 10% problem, that you can kind of avoid solving a proportion by looking at patterns and numbers. So if we look at the second item, it's asking us, what if I start with $50 in my bank account and it increases by 6%? We can still set it up this way. You can set up another proportion and say $50 is your 100%. If it increased to 6%, what is that new amount? You could still cross multiply and divide, or you can just notice for patterns in your table like we did back in Unit 2. I noticed that 50 is at half of 100, so then I can just follow that same pattern and take half of my number right here. So if I take half of 106, that's just going to give me 53. And again, you would get the same thing in your calculator if you did 50 times 106 and divided it by 100. But percentages, it really just goes along with proportional relationships. And if you find those patterns in the table, you can use that to fill out the rest. We can do the same thing if we're looking for $200. So what if I start January 1st, I put $200 in my bank account. Again, I could set up my proportion and say $200 is my 100%, how much is my 106%, cross multiply. But if I'm looking here, I also notice that I can take $100 in my table and multiply it by 2, so I can do the same thing over here. If I set up a table, I can complete it just like we did in Unit 2 with all of the constant of proportionality and scale factor things. So if I take 106 and multiply it by 2, it's not letting me draw on it. I don't know why, Elena. Maybe try to refresh. I can see a lot of, I can see some of your screens working on it, so I don't know if it's just a connection issue that you have, or if you just want to use your book, you can do that. It's on page, what did I say, 62, I think. Multiply this by 2, so 106 times 2 is 200. 212. But again, you can still set it up like your proportion. Your proportion is always going to work. So if we look for that final amount, what if it is $125? I don't necessarily see an easy pattern here. Maybe you do with some of the numbers, breaking them up into parts, but I really just like to think in terms of scale factors. I don't really know what scale factor takes me from 100 to 125, so I'm gonna set this one up as a proportion. And I'm gonna say, if I start with $125 in the bank, that's 100%, that's my starting value. It increases by 6%, so that means at the end of a year, there's 106% of what I started. I need to know that final amount. Once that's set up, you go through your cross multiplication and your division. So 125 times 106 divided by 100, we get 132.50. That's everything that we should know how to do right now. Read through a problem like that, set up your proportion to solve it. And again, if you notice some of these tricks and shortcuts, you can use them. Our goal for today is to eliminate this whole method of solving a proportion. You're always going to be able to use it if you prefer it, but we're going to talk about how can I set up an equation and go through just a simple rule. So again, if we think in terms of what we did in Unit 2, I'm going to erase some of this stuff so that it's not so much that we're looking at. I want all this. So if we think in terms of Unit 2, if I just gave you this table, not talking about percentages, not talking about anything crazy, I just gave you this table and I told you to find your constant of proportionality and write an equation that matches it, we should know how to do that. So if I think about that, if I'm looking here and I have to figure out if it's proportional, we know that we have to divide the right side by the left side. So if you have your calculators out and you divide 106 by 100, 53 by 50, 212 by 200, if you do that all the way down, you're going to recognize that your constant of proportionality in the table is 1.06. So again, like we talked about in Unit 2, that tells us that we can take anything that's on the left side of the table. So in this problem, we can take the initial amount that we put into the bank. If I don't know what that is, I can call it X. And if I multiply it by 1.06, it's going to give me the final amount. So notice how that constant of proportionality relates to the language in the problem about your percentage and how we're writing it. If I have 106% and I convert that into a decimal, we should recognize that percents into decimals, we did that a couple weeks ago. If you take your percentage and divide it by 100, that's going to give you your decimal. So if I'm working with a percentage and I think about it as a decimal, my decimal version of 106% is 1.06. So really all that we're doing whenever we're solving these percentage problems is taking that original value, multiplying it by the percentage. The only difference is that it's written as a decimal and not a percent. And that's going to give me the final amount. So again, I take the original value, I multiply it by the percent increase or decrease, that's going to give me the new amount. So instead of setting up and going through that whole proportion thing, if I just recognize that an increase of 106% means that it's 106, as a decimal would be 1.06 because you're taking that and dividing it by 100, then all I would have to do is take all of these initial amounts and multiply by that value, and it's going to give me everything over here. We're going to look at another one of these, and instead of talking about a percent increase, it's a percent decrease. But the basic format of our rule or our equation is right here. So even if you have your book out, if you write any of this down, make sure it's something like this. Our rule is that we take the original value that we're starting with, multiplying it by that percentage. But the way that your calculators work, you just have to convert it into a decimal. So we're multiplying it by that percentage as a decimal, and that gives you the new value. So if we look here, I'm going to give you a second to maybe try to think about this to fill out a table. So the value of a new car decreases by about 15% in the first year. So I'm going to get this set up for you so you can see what I want you to do. How much will a car be worth after 1 year if its initial value is $1,000 $5,000, 520, or X. So X, again, is your original amount or your starting amount. Y is how much it's gonna be worth after a year. So I have to figure out if my car is originally worth $1,000, how much is it worth after a year? What if it's worth 5,000? What if it's worth 5,020? And then what if you don't know how much it's worth? So try to see if you can find the right side of that table. Pay attention to the language. It's decreasing by 15% each year. Even if you're still not sure about the equation pattern that we just looked at and you want to go through the proportion thing like I did first on that other slide, you can. But try to see if you can find how much the car is going to be worth. If it starts out at $1,000, what if it starts out at 5,000, 5,020, and then try to find the rule in that table. And then, yeah, if you're working in your book, like I see a lot of you doing, just tell me on here, perfectly fine. I know it's a pain to write in here. Keep in mind, I already see a little teeny tiny mistake, the most common mistake in problems like this. If we're setting up that proportion, if you're decreasing by about 15%, remember all of this work that we've been doing, we've been starting with 100, and then what does that decrease of 15% actually mean? So make sure you're doing that step when you're working through this. So if you are doing the proportion method, perfectly fine. This is the last slide we're gonna do that on though, because we're gonna practice then with that rule. So if we're still a little bit stuck on how to set it up, go with what we did last week, set up your framework, start with your original value. My first original value says that I buy a car for $1,000. And typically what happens is that when you buy a car, the more that you drive it, you're using it, maybe you wreck it a little bit, it's not worth the same amount that you bought it for. So after a year, it decreases in value by 15%. So when I buy it for $1,000, it's 100% brand new, everything's good. If it decreases by 15%, again, we have to think about what that decrease is gonna be. So if I take that 15% away from 100%, we get 85%. So then we just have to figure out what is that value. Once you have that, do your cross multiplication and dividing, and we get that after a year, your car that was originally $1,000 is only worth $850. We can set up another proportion to solve the next one. I can replace my $1,000 with $5,000, cross multiply and divide. But again, if I recognize an easy pattern, 1,000 times 5 gives me 5,000. So 850 times 5 can give me 4,250. So if I buy a car worth $5,000, after a year it's only worth 4,250. What if I buy it for 5,020? I don't see an easy pattern there, so I'll set up my proportion. Originally it was $5,020. That was 100% of its value. It was brand new, nothing happened yet. I drove it around for a year. It got a little used, so now it's only worth 85% because it decreased by 15. So what is it worth? Do your cross multiplication and your division, and you get 4267. So then that last part is saying, well, what if I don't know what that initial value is? What number can I use, or what number am I multiplying everything by over here to figure out that value? We can do the same thing we just did on that other slide, find that constant of proportionality. So if I divide everything right to left, just like we did before. 850 divided by 1,000, 4250 divided by 5,000, whichever one you pick, you're gonna notice, again, that your constant of proportionality is 0.85. So that means that we can take all of our initial values, multiply them by 0.85, and that gives us the new value. And again, notice how that relates to our percentage. 85% as my decimal divided by 100 is 0.85. So all that's happening in these percentage problems, like we just said on that other page, you take your original value, multiply it by your percentage, and we just can't type percentages into the calculator, so we convert them into decimals. So you multiply it by that percent change, whether it's a decrease or an increase, and that is always going to give you your new value. So that's what we're gonna practice doing with the rest of our questions. Figure out what that percent increase or decrease is, always based off of 100. If I decrease by 15%, then I'm subtracting it. If I increased it, then I would add it. I take that percentage, multiply it by our original amount, and that's always gonna give us the new value. So we're not gonna do any more work with these proportions right now. We're not gonna set up any more tables. Just wanted to do that to point out where that number was coming from. But all we're doing is taking that value and multiplying it by the percentage. So I'm gonna change your screen, and we've never done one like this before. You have a matching screen. So each of those word problems matches up to one equation. You can tap and match, and then like when you get one, it will turn red. Or when you get it right, it will turn green. If it's wrong, it will turn red. I can see kind of how many attempts you make, so if you're just kind of clicking around to get it. But you're just reading through. So the first one I see says that the water level in a pool is now 52 meters. If this was a 23% increase, what was the initial depth? So to help you, again, the format of our equations tells us that we can take the percent change. We can take the percent change times the original value, and that's going to give us the new amount. So read through all four of those problems, figure out what the percent change is, figure out if the number given is your original amount or your starting amount, and see if you can match them all up. And then I can see here, I've never done this, so I'm just interested. I can see how many matches that you have and how many tries it took you. So again, if you just keep trying to like tap, the more tries you get, the more I'm gonna assume that's what you're doing, but we're just getting practice. So see if you can match them all up. Take a couple seconds to get all the matches, and then we're gonna go over it. That's fine, Heather. I just saw your comment on the book. The only issue is that if you are in the book here, some of these are given, but I added a couple extras. So even if you just look at my screen and just make little notes in your book about what would match up, that's fine. So as you finish up, I'm gonna start going through. So I'm gonna read through. Water level in a pool is now 52 meters. If this was an increase of 23%, what was an initial depth? So really the only thing we have to pay attention to, because if we look at all of these equations, they're all kind of the same. I have some value equal to 52. So I really just want to look at the percentages and figure out what's going on. So in this first problem, I have an increase of 23%. So again, if I'm thinking in terms of percent increase from 100, if I have 100% and I add 23% to it, that means my total percentage is 123. But now our rule says that if I want to solve a problem like this, I can take an initial value, multiply it by 123%, which as a decimal is just 1.23. So which of those equations shows us multiplying something by 1.23? I'm going to highlight this one in green. I'm going to change my colors. I can see here that my percentage value is 1.23. So that's how you represent an increase of 23%. The next one says that you bought a dress on sale for $52. You received a 23% discount. So if I discount something by 23%, that means I took my initial value of 100%, and I took 23% off of it, so then what percentage is left? Our actual percentage that we would be working with in the problem is 77%. So which equation shows using a percentage of 77%? If I take that and convert it into a decimal, 77 divided by 100. Change into my highlighter. You would recognize that we're over here. So anytime we're talking about a decrease of 23%, it actually means we're working with 77%. The number of students who signed up for a club increased by 77%. So if I increase something by 77, that means I'm adding it to 100. So I have 177 total percent. Which equation shows an increase of 177%? 1.77, which leaves our final option here. The snow is now 52 inches deep. If this was a 77% decrease, if I take 77% away from 100, that leaves us with 23%, which we can see that value right here. So that's the main idea that we're going to work with on the next few questions. You take your initial amount, figure out what the increase or decrease is, always based off of 100, and all we have to do is multiply it through. So if we look at the next one, I'm going to show you this and then have you work on the one after this on your own. We had a couple homework questions similar to this the other day, and we solved them as proportions. Now we're going to see how simple it is that we know these new rules. This says that the gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more than that. How much does the truck's tank hold? And again, our format for equations is always the percent change. If you're in the book, I believe now this is maybe on page 63-ish. So we have percent change times the original, or like your starting value, and that gives you the new value. So once I know that framework, we're just going to process through the problem to think about what numbers we know. The gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more. So I'm going to start with the percentage part first because it's typically easiest. So 50% more means I have 150%. All we have to do is convert that into a decimal. So we would divide it by 100. If we divide this by 100, you get 1.5. So that means my percent change is 1.5. So now I just have to figure out what the original value is. I'm basing everything off of the Dad's truck. I said that it had 12 gallons. The Mom's truck was 50% more. So in this context, this 12 gallons in the Dad's truck is your original value. So I would take the 12 gallons that were in the truck, multiply it by 150%, and that's going to give you how much is in the Mom's truck. So whereas on your homework, you had to set up that whole big long proportion and figure out all your parts, all we have to do here is determine what that percent change is and multiply it by our value. So 1.5 times 12 gives 18. So how much does the Mom's truck hold? 18 gallons. So it should be a little bit simpler. Figure out that percent change. If it's more, then you're adding it to 100. If it's less, then you're subtracting it. Figure out that decimal value, multiply it by your original amount. So try to do that on the next one. Movie theater decreased the size of its popcorn bags by 20%. The old bags held 15 cups. How much do the new bags hold? I'll leave this up so you can see it. Tell me how much the new bags hold. Like I said, some of these problems we had on homework the other day, but we set it up as a proportion to solve it. It's a little bit more work, it's a little bit more challenging to read through and understand what parts we know. But now this new rule always can be used. What is the percent change? Multiply it by the original amount, and that gives you the new amount. So I see some of you still doing a proportion, which is fine. If you're fine with the proportion way, you can keep solving it like that. It just typically, it's a popcorn bowl. I always make my popcorn. I don't have a glass bowl like that, but I do have a fancy popcorn bowl. I eat a lot of popcorn. If you're still doing a proportion method, that's fine. If you're fine with doing that work, always gonna work. But I know some of you eventually like doing less work, which is why we have this equation method here. So first thing I wanna recognize is what is that percent change? If I decrease by 20%, that means I'm taking 20% away from 100. So our percent change is 80%. Then you just wanna convert that into a decimal, which would be 0.8. And if you still don't understand what's happening there, you just take your percentage and divide it by 100. All that I have to do then is take that percent change and multiply it by the original amount. So I'm gonna read through it again to make sure that this 15 is my original amount. If the old bag held 15 cups of popcorn, how much do the new bags hold? So then I take my 80% change, multiply it by 15, and if we go through with that and do our multiplication, it's gonna tell you how much is left over, which we end up getting, I don't know my final answer, 12, I think, 12 or 13. 0.8 times 15 is 12 cups. So again, if you're okay doing your proportion, you can do that, but I do want you to recognize how the equations are set up because your homework is gonna have a couple questions geared towards that. So you do wanna recognize that the framework is always the percent times original gives you new. If you're just stuck in the proportion world, you're gonna be a little bit confused on that. Okay, last one I'm gonna give, I think, maybe we'll do two more. Try to work on this one. Let's close this, flip this. After a 25% discount, the price of a t-shirt was $12. What was the price before the discount? It's a little bit different. Little teeny tiny bit different. Again, pay attention to the framework. Your percent change times the original value is equal to the new value. So you may have to read through the problem to think about what is given to you. Are you given the original amount or are you given the new amount? So if we have a 25% discount, we should be pretty comfortable knowing how to get started with this point. Take 25% away from 100, that means our percent change, or our percent that we're paying is 75%. As a decimal is 0.75. Times the original amount equals the new amount. So we're gonna read through this one again. It says, after the discount, the price of a new shirt was $12. What was the price before the discount? So this is one that is worded where we know the new sale amount, we don't know what it originally was, right? That's what it's asking. What was the price before the discount? Is saying, what was the original price? So I don't know what that original price is, but I know that this was $12. So now I have something that looks like this. 0.75 times some value is equal to $12. So this is something where we would be working backwards. We looked at a lot of tables in Unit 2 where we had a number on the right and had to go back to the left. So if typically I multiply to get my final answer, if I have to go backwards to figure out that original amount or that starting amount, how do I go backwards from multiplication? We would divide. So if you're looking for that original amount or you're going backwards, our operation that's backwards from multiplication, again, is always division. So we're not multiplying by that percent change, we're actually gonna go ahead and divide. So if I take the $12 sale price and divide it by the 75%, we get that it's $16. And again, this is one where you would even have set your proportion up a little bit different if you went through it that way. We have that $12 was the sale price, which I know the sale price was 75%, but I don't know what the 100% original value was. So you would have set it up like that. Or if we're doing the new roll, where typically I take the original value times the percentage, I don't know that original value, that means I'm going backwards. Opposite of multiplication is to divide. I'm gonna leave one more on your screen for you to do before the end of the period. Compared to last year, the population of a town has increased by 25%. The population is now 6,600. What was the population last year? So again, percent change times your original amount equals the new amount. So figure out what you know. What's the percent change? That should be the easy part at this point. An increase of 25%. Then read through and decipher that 6,600. Is that the original population that we were talking about, or is that the new population that we were talking about? Give you a minute to look at that before I go through it and then get you started on your independent stuff. It's okay, Sita. Perfect. Be careful, Sydney, it's a 25% increase. I don't know what that 75 is that you're doing. So if I increase by 25%, 100 plus 25 is 125%. As a decimal, 1.25. Then I think through, well, what do I know? Do I know the first population I counted, or do I know the second population? So I'm gonna read it again. Compared to last year, the population increased 25%. The population is now 6,600. What was it before? So all of these words, initial, original, before, past, that's all your starting amount. So if I need to know last year or before, that means I don't know what it originally was. What is it now? Or what is the new amount or the markup or the discount? That's always your new value. The language is just a little bit different depending on the context of the problem. So we have another problem where we're looking for that original amount. So again, anytime we're going backwards, instead of multiplying, If I need to figure out what number I multiply by 125, that means I just have to divide. So I divide both of my sides or both of my numbers by 125%. So whatever that number is, I don't remember it off the top of my head, 66 divided by 125 gives you 5,280, and then always try to make sure you have your unit, which I'm kind of bad at that, but, okay. So as far as ninth period goes, there's an ed puzzle, there's some practice problems. The answer key is gonna get posted at some point next period once I run through it. If you have questions, sign in for ninth period and I will help you with that. If not, you can get started on all of that stuff right now and enjoy your weekend. Bye, guys.